Hi, my name is Austin King.
My name is Robert Martinez,
I'm Eric Mercado.
and together we make up the Intelligent Ground Vehicle team here at UCI. The goals and objectives of this team are to design an autonomous ground vehicle capable of competing at the Auto Navigation Challenge in the IGV competition. That competition will be held in Michigan in June 2020. Our objectives for this quarter were to demonstrate functionality by reading the average velocity of our vehicle, which must be between 1 and 5 miles per hour, that is set by the competition, must be capable of autonomous object avoidance, and must be capable of carrying a 20-pound payload. The goals and objectives essentially carried over from last year's team, and we picked up where they left off the work.
For the Gantt chart, pretty much the first couple of weeks we focused on programming using Python and completing tutorials on Code Academy. We first decided to work on the Raspberry Pi as our microcontroller, but around week 7 we decided to use the Jetson Nano for our microcontroller. At the end of the quarter we decided that we were going to test the components, test the ultrasonic sensors, see if we can get the camera going for lane tracking, and hopefully implement a GPS system as a waypoint navigation. That's for the Gantt chart.
So as far as progress is concerned on the software side of things, we have it currently all in Arduino. We don't have the Python-based microcontroller yet that we plan to implement to use lane detection and stuff like that. So we just have an ultrasonic sensor ESCL hooked up to the Arduino.
And then on top of that, we redesigned the chassis and the control arms. So as shown in the CAD design, we decided to use 1 inch by 1 inch aluminum square tubing, 6061 aluminum, and that was used throughout mainly for convenience for our fabrication skills and for budget.
Here you can see the wiring diagram and the block diagram showing the schematics for it as well as its logic process. So here on the wiring diagram, like I said, we have the single ultrasonic sensor, Arduino, electronic speed controller, 2 motors, and our battery. This is for just like demonstration purposes for the end of the quarter. The end system will also have another ultrasonic sensor as well as the Jetson and webcam for lane detection. And then right here you can see the block diagram for the software it's currently running. It's very simple. It currently just runs as, is there something in the way? Then stop, and if there isn't, then go. And for future works, we plan to add, like I said earlier, the Jetson Nano in order to add lane tracking to it.
On top of that, on the mechanical side, we still need to design a suspension system and a propulsion system, and we are planning to avoid having to design a steering mechanism by using essentially a chain-driven system.